1 and the negative u that are already there. So it's negative integral of u to the 56th minus u to the 57th du. And then we get this negative, so we can multiply that in. Get the integral of u to the 57th minus u to the 56th du. All right, then we want to take the integral. This is just a simple power rule, so we're going to take the integral of a power. It's going to increase the power to 58. And then we're also going to need from looking at the power rule, we're going to need a 58 out front that we are going to bring up into the exponent. So there was a 58 here, but that also means that we need a 58 on the bottom in order to counterbalance. Okay, minus u raised to the 57th power. For the same reason, we're increasing the exponent by 1, and divide by 57. Plus c. Then what we can do is go back to the original and say u is equal to 1 minus x. So this is going to be 1 minus x raised to the 58th power divided by 58 minus parentheses 1 minus x to the 57th power divided by 57 plus c. That is the integral of x times 1 minus x raised to the 56th power dx. All right, one example of like a different kind that we might find here is the integral of cosine raised to the third of theta d theta. By itself, it doesn't look too bad. You might think, oh, it's a power rule. Great. What is the u function that you're going to pick? If your u function was just cosine of theta d theta, then what's du? Well, that's going to cause us to have a bit of a problem here. Because again, we don't have the other piece that should be here, that normally is here. So instead, what we can do is we can split this out into the integral of the cosine squared of theta d theta. Well, not yet. Cosine squared times cosine of theta d theta. And again, it would be really nice if we could use these cosines in some way. Again, looking at this in terms of our function, if we have a cosine function somewhere, its derivative should be a sine function. But luckily we can go the other way. If cosine is the du function, then the u function has to be a sine. Well, how do we get cosine squared to be something with sines? Right, it's going to be cosine squared of theta is equal to 1 minus sine squared of theta. And then multiplied through by the cosine of theta d theta. You get the integral of the cosine of theta d theta minus integral of sine squared theta cosine theta d theta. Let u be the sine of theta. So du is going to be equal to the cosine of theta d theta. We have cosine of theta d theta exactly, so that's just du. And then here we let u be equal to the sine of theta. So here this is the sine squared of theta. This is u squared. All right, and this stuff is actually doable. So what is the integral of the cosine of theta d theta? That is going to be the sine of theta. Plus c will, plus c will wrap up all the way at the end. Here we've got a minus integral of u squared du is going to again be 1/3 u to the third. And then plus c at the end. So we can get a sine of theta minus 1/3. U is again the sine of theta, and we're cubing it. So sine cubed of theta plus c. And if you can't remember what you were doing, maybe write that all over again. All right, let's try this. I'm getting that this is probably not impossible, but not particularly nice. So integral of sine squared theta minus 2 sine of theta times sine cubed theta minus 3 sine squared of theta parentheses cubed cosine of theta d theta. Alright, so with this there are a few things that we can do. We can try to combine as many like terms as we have. We can try to multiply this stuff, all of the sines stuff out, leave the cosine of theta here, and don't try to change any of these sines to cosines. It would be really good if we could just multiply by cosine of theta d theta to everything and then be done with it. Right, we would not need would not need any other du terms. So this is going to be, I might suggest multiplying this out as best you can. At the moment, just leave this. So this is going to be the sine squared theta minus 2 sine of theta, parentheses. No. That's what I forgot. Alright, so we can factor out a sine of theta from both of these two terms. We're left with a sine of theta minus 2. This stuff here has two signs in common. So if you want to take out a sine squared, and then here you have to cube it. Since it's multiplied, this is actually a perfect opportunity to use this. So take out sine squared from both terms, and then cube it. So sine squared cubed is going to be sine to the 6th of theta times the quantity. Here we just have one sine of theta left over. And then we have 3. That's it. Just 3. Cubed. And again, cosine theta d theta. Here these two terms can combine. Here, might have to actually just multiply everything out. As much as I hate it. All right. So here we have sine of theta minus 3 all cubed. If we basically we're just using Pascal's triangle on this. This is not surprising. You all know I love it. Here we have the sine cubed of theta minus 1 of these and 2 of those is going to get us a minus 3 sine squared theta times 3, 4 being the position. All right, in Pascal's triangle, this is 1, 3, 3, 1. So if you have mixed cases in the middle, these are going to end up doing something to the constants here. All right, 2 3s is going to be 9 multiplied together. 1 sine, and then here we have a 3 from the natural 3 from the Pascal's pattern. All right, so 1 3 3 1. Here, because we have 2 negative 3's, that's going to be squared, so it's going to be positive 9 times sine of theta times the 3 that was already here, so that's 27 sine of theta. And then if we cube negative 3, that's going to be a negative 27 cosine theta d theta. All right, so integral sine of the 7th of theta times, this is where it gets a little interesting. We're going to have here sine to the 4th. This is going to be sine to the 3rd, and this is going to be sine to the 3rd. So this is going to be a minus 2 and a minus 9, a minus 11. Nope. Alright, now squared is going to be negative 2 times the negative 9 is positive 18 sine squared. And a sine times the sine here is also going to be sine squared. So that's 18 and 27 is going to be 45 sine squared theta. Hey, Kiwi Gamer Romania. How's it going? And then we're going to multiply through again to get singles. So here, negative 2 times positive 27 sine. It's going to be a negative 54 sine of theta. And that's going to be a negative 27 on top of that. So that's going to be negative 3 27s. So 81. And then we also have a negative 2 times a negative 27 is going to be positive 54. Alright, take all that. Multiply by the cosine of theta d theta. Alright, well, glad to hear you're doing alright. Anything going on that's interesting out in the world? Whether yours or somebody else's, that's fine. Here, raised to the 7th power, or sine to the 7th power, is going to get us sine of, nope, sine raised to the 11th power of theta. Jeez, man, come on. Of theta minus 11 sine to the 10th of theta plus 45 sine to the 9th of theta minus 81 sine to the 8th of theta plus 54 sine to the 7th of theta, all times cosine theta d theta. This just means that this is going to be yet another polynomial. Trying to finish the entire Romanian high school math curriculum needed for final exam. Hardest program in under a month. So I can finally start university stuff without missing a single prerequisite. Yeah. I can imagine. That's a bit of pressure. So, bit busy. I certainly do not blame you one bit for going on vacation. At least for a little bit. Yep. Trying to do the entire high school 4-year math curriculum in a month. Yep. Yep. It's pretty intense. I mean, technically it's 1/48th, but like, would you actually be in school the whole time? Or, of course, I also don't know how, right, I don't know how your country does it. So, in the United States, we get the summers off, so that's why. I mean, that's one reason I'm here. No. It's still insanely hard. Alright, we can let u be equal to the sine of theta du equals cosine theta d theta. We have that here. That's du. And then going all the way across, just the sine of theta is u, so this is going to be u to the 11th. That's 11. U to the 10th plus 45. 25 u to the ninth minus 81 u to the eighth. It's 54 u to the seventh. Yeah, normal pace. A year and a half a year would be good enough to slow down, calm, chill, succeed. Have too many interests in math and science. Only way to satisfy a portion of them is to start as early as now. Yeah, that's fair. As insane as it definitely feels, I'm sure. All right, take the integral here. We're going to get 1/12 of u to the 12th. Here, this 11 actually comes up and becomes part of the next exponent up. In fact, it becomes the entire next exponent up, so this is minus u to the 11th. All right, 45th, we want to take a 10 up. So you could either say that this is 45 over 10 or 9 over 20. Wait. Hang on. No, 45 over 10, which is 4.5, which is 9 over 2. Okay, much better. U to the 10th minus, this is going to become a 9, so we're going to take a 9 out of 81. We're left with 9. Negative 9 u to the 9th plus, we need to take an 8 out of 54. Well, we can take a 2 out anyway. So 27 fourths u to the 8th plus c. Oops, wait. No, I can't do that yet. Then we got to plug the sine of theta back in. Sine 12th of theta divided by 12 minus sine the 11th of theta over, nope, just minus that sign, plus 9 halves sine to the 10th theta minus 9 sine to the 9th of theta plus 27 fourths sine to the 8th of theta plus c. Okay. Improper integrals should not be on the high school curriculum unless y'all are doing Calc 2, which, you know, probably not. Yeah, so this actually is Calc 1 type stuff, but I picked, like, I did an easier problem up here. Oops. Ah. Not that. Yeah, I did an easier problem here. Where I said, let's have integral of cosine to the third of theta d theta. And the way to do this really is to split this up into two functions, a cosine squared and a cosine, and then say, well, if we want a function and its derivative, cosine and cosine isn't going to work, but we can translate a cosine squared into a sine squared. And so trade that out, doing normal trig stuff. When we multiply all this stuff out, then we got one straightforward integral and one that we had to do a u substitution on, which then allows us to get this thing, which then allows us to plug in this other stuff down at the bottom. Yeah, this one was okay too. Similar type thing. Having the 1 minus x inside this really high power was really inconvenient. So what we did was we said, okay, let's switch and have just plain old u be 1 minus x. So here this is just u to the 56 power, and then x could be translated to 1 minus u, which then allows us to multiply this stuff together, again, very simply, which then allows us to take integrals and get all this stuff. So, anyway. Alright, so, do you have any particular questions that you would like to cover? Because you have quite the exam coming up. Yeah, if there are any, any particular areas that you're not 100% on. Didn't encounter anything hard. That's good. Means you're probably in a good shape. Fields and rings. Wow. That's pretty intense. That's abstract algebra. We don't actually cover that in the United States at all until, I mean, we talk a little bit about rings, like cyclic subgroups, when we talk about imaginary numbers or complex numbers. Because when you raise I to a power, it creates a 4 cycle. We've talked about this before here. I don't remember if it was you or Matthew, but either way. Yeah, I have access to a bunch of AMATIC, which is the American Mathematical Association for two-year colleges, math exams from years past. And, you know, some of the stuff that they're always interested in doing, you know, the sum of 3 cubes is equal to the current year. They love doing that stuff. Now, there aren't necessarily going to be just the sum of 3 cubes which get the current year. We could, for instance, need to, for this particular year, make it the 4th power of 3 different numbers or 2 different numbers. Yeah, we studied a bunch of